Hello and welcome everyone to YouTube channel of DCC and NIT-A. Myself Govind Singh, and today we will be solving the problem flip the prefix which was asked in Codechef starter 71. So the question says there is a binary string s which is of length n, and there is an operation like we can choose a prefix of s and flip all the characters in it. Like if there is a 1, then we can convert it to 0, and if there is 0, we can make it uh, 1 or 0, like this, vice versa. And we need to tell the minimum number of operations that are required to obtain. We need to make a substring of length k, which is having all ones, and this substring should this string is a substring of this main string like s. Okay, so we need to do operations on this string s such that there is a substring which is of length k, which is having all ones, and we need to make the minimum number of operations as possible. So we don't need to make this subarray. We just need to print the minimum number of operations that are required for doing this. So I hope this what is prefix and substring is clear to you. Let's see the sample test cases. Like if we see this sample test case, here k is 3. Like, so we need substring of size 3 which is having all one. So we need this in this string. There should be this. So to convert this equal to this, we can choose a prefix like this. So choosing this prefix, we can convert all this prefix, we can flip all this prefix, and it will become 111, and it would be in one operation. And like here in the next test case, now here we need a substring of size 2 which is all ones. Now here we can here we already see there is already this present already available a substring of size 2 which is having all ones. So the number of operations required will be 0. And talking about the third test case, if it is 10101, if we choose any of these substrings, like if we choose this substring and we make it flip, if we choose if we want to make this substring equal to 111, so how can we do it? Like we can flip this 0 into 1. Like if we want to make this 0 equal to 1, we cannot do it just make this equal to 1. We have to choose this whole prefix, and then we just flip all of them. Like it would be 1 0 1 0, like after flipping. Okay, after one operation, the this would be like this. uh, and now we want this equal to this, so this is one operation. Now we again do one operation and make this equal to 1. For making this equal to 1, we again need to choose a prefix and swap or flip all the elements. Now it would be 101, and this is the substring that we require. So the number of operation would be 2. So the sample output is 2. So I hope now the problem is clear to you. So this question, it requires two concepts, and we will learn both of these concepts in this video. So it's a very informative video. We will be knowing prefix array plus suffix array in this video. Yeah. So first, for creating this prefix array, now what can we do? Like, see, first of all, there is, suppose consider a string like which is of length 6. I'm taking any random string, like maybe 0 1 0 1 1 0 1. So uh, how can we create a prefix array? Okay, which prefix array we are creating? Okay, so here prefix of I will denote the the number of operations required to make all the previous values equal to the ith element. Okay, so if we are at this index, okay, and we want to make all of these, okay, what will be the prefix of I? Okay, if we create a prefix array which is equal to this, which will also be of size 6, then what will be the ith element? It will be equal to the number of operations required to make this subarray equal to this element. Like if we have to convert, we have to make all these elements equal to 1. So so prefix of I, it will be equal to that. Now how can we achieve this? So we start off with this index. Like here we can see, before this, what is the number of operations that are required to make the all the previous element of this value, all the what are the previous values? Like there is no previous value for the first index, of course. So it will be 0. To make all the previous values equal to 1, it requires 0 operation because there is no value. That's why. Now for making all, now for the next index, for making all these value equal to this ith element, like it is 0, to make all these value equal to 0, number of operations would be required. It will be like there is a 1, so we need to make flip it, like it would require only one operation. So but could we make use of this value we have already created, right? So let's see, like 0 operations are required to make all of these previous elements equal to this, right? So these all elements will be equal, all this prefix will be equal, and so 0 operations will be required to make this substring or this prefix. Okay, so this prefix equal to 1, it requires 0 operation, and from this prefix to convert, this will be all ones. To convert these all ones into all zeros, it will be require only one operation. So it will be this value plus 1. Okay. So if it is not clear, I will be checking for all the indexes. So no need to worry. So if we check out for this index now, okay, okay, this is one we have calculated. Now if we check for this index, now we can see what is the number of operations. What is the prefix of I? It is the number of operation that is required to make all the elements prior, that are previous, all the previous element of this value equal to this element. Okay, like all the previous values this is the ith element. Now these are all its previous value and we want to make all these values equal to 1. So how many operations do we require for that? Now the number of operations required to make, we know that number of operations required to make all these values, all these values, indeed all these values equal to 0, it would be 1. Yeah, to make all these value equal to 0, it would be 1. So that means these all values are 0 and this is also 0. So these all values will be 0 in one operation, after one operation. So so these all will be 1. To make all these equal to this so these all will be 0 actually. To make all this equal to 0, it requires one operation. To make all this equal to 1, what do we require? We need to make a single flip. Only one operation is required. So it will be, this previous element plus 1. So it will be 2. Now let's again check for the other index. So now we can see, now to convert all these previous elements equal to this element, how many operations do we require? Okay, so now the number of operations required to make all of these elements equal to 1, it is 2, and it is also 1. So number of operations till now which that we have done to make all of these elements equal to 2, it is also, it is 2. And also that it is what we require in 1, like the number of operation that is required to make all of this array as 1, it is 1. Okay, so it is 2, so it will be 2 only. So again let's see. So for 0, the number of operations that are required to make all of these elements equal to 0, how can we find it? Like it would, we know the number of operations to make all these as 1, it is 2. Now to making all these as 0, what we need to do? Like we need to make a single flip of this prefix, like it will require one operation. So it will be 0 0 0 0. So it requires three operations. Now, can you see a pattern here? So there is a pattern. Like what we are doing, we are adding the previous value. Like 2 is incremented. When it is incremented, like 2 will be added to 1 if there is a difference. Like here we can see the initial value would be 0 only. Now here we can see, like for this index, previous value plus, is there a change? Yeah, is there a change? Then we increment 1 to this value and put it here. Now is there a change here? Like yes, there is a change. So what we'll do, we increment 1 here, 1 here will be incremented. Now here we can see, is there a change? No, there is no change, so it will be 2 only. So is there a change? Yes, there is a change, so we increment 1. So is there a change? Okay, so it would be 4, like increment 1. This is the observation, but also we have done, we already know the concept, like how and why it is happening. So the prefix of I, it is it is actually the number of operations required to make all of these elements as one. Like if we talk about, if I is this, the number of operations required to make all these equal to 1. And we know that 3 operations are required to make all these as 0. Now to make all these equal to 1, we need one more operation. So that's why I added 4. And it would be all ones, right? So this is the suffix array that we have created. Now let's see how can we use this suffix, this prefix array, right? So let's write here it again. I guess it is a suffix array. Sorry, the string. It is 101101, and its prefix array is, we have calculated, it is 0 1 2 2 3 4. Now in the question it was asked like k is given, like we need a substring of size k. Like if k is 3, we need a substring of size 3. Like we need this. So can we convert any of this string equal to this? Like and for doing so, how many operations do we require? Like take any string. Like if I take this string, this substring. So how many operations do I require? Okay, without my logic, if I'm doing like then how many operations do I require? Okay, so I can see like here is a 0, so I will convert it to 1. Like starting from back, I will convert it to 1. Like I will make it 1. Flip all these, it will be 1 0 0. Like making now again, I choose this prefix and flip all, like it will be 1 1 1. So I require 2 operations. But can I use my prefix to get this? Let's see, prefix array. Yeah, so I can see that now I will, here it is an index 0. What this 3 will denote? Now 3 tells like what is the number of operations that are required to convert all this array as 0. All the prefix of this, element as 0. So 3 operations are required to make all of these as 3, right? Okay, so we need to make a sub array. Okay, what is important to us? Like it is only important, like we need to make this array equal to this, right? We need 1 1 1, but it is the operation required to make all of this as 0. So actually we don't care about these two, we need to make this equal to this. So why we are caring for them? Okay, what is this 2 denote? This 2 denotes the number of operations required to make these two elements, like previous, like which is the prefix of this one, like the number of operations required to make the prefix of this 1 equal to 1. So this 2 we just don't require to, because we don't need to care about these. We only care about this particular window, that is which is of size k, which we have to convert to 1 1 1. Okay, so what we will do, we will subtract 2 from 3. Like if we subtract 2 from 3, now this is the number of operations that we need to make all this substring as 0. To make all this as 0, like uh, it is 1 1 0. To make all of this 0, like we can select this and flip it. Now it is the operation required to make all of this as 0. Now if we add a 1 here, now this is the operation required to make all of this as 0. Now if we add a 1 here, now this is the operation required to make all of this as 0. Now if we add a 1 here, now this is the operation required to make all of this as 0. Now if we add a 1 here, now this is the operation required to make all of this as 0. Now if we add a 1 here, to make all of this as one. Now we can make it become 0 0 0 using 3 2 operation, and we added 1 because it is 0 and we need to make it 1, so one more flip is required. So in total 2 flips are required. So let's take another window, like let's take another part and try to think like how can we solve it. Now, if we take this substring, if we are taking this substring and we need to make this substring 101, this substring is 101 and we need to make it as 111. So now what is this 4 denotes? It denotes the number of operations that are required to make all of these as 1. But we don't care about these elements. We don't care about these 3. We just care about these 3, which is the size of our window, that is k. Okay, so what we do, like we subtract these 2 from this. Okay, because this 2 will denote the number of operations required to make all these as 1. Okay, so we will just subtract this 2 from this 4. So for this case, what we will do, like we will subtract 2 from this 4, and then it will be a one size array, like it will be a sub array of this having all ones. And now we don't need to add another one here. Why? Because it is already one. Is already one, or a prefix of containing all elements as one. So now can we write a formula to find this? So if I am at ith index, like this is the ith index, so what will I do? Like, and this, what will be this index? The size of window is k, so this would be I minus k plus 1. Okay, so um, so what the total number of operations that are required to make this window equal to this, like this substring equal to 111, like how many operations are required. What we'll do, we'll subtract prefix of I and subtract prefix of I minus k plus 1 from it, and then we add a 1 only if the string of I equal to 0. Like in the previous case, the string of I equal to 0, then we added 1. So we will add string of I equal to 0, and if it is 0, then it will be added, like it will give true, and true means 1. Okay, so by doing this, by using this formula, what we are doing, we are finding whether what is the number of operation that are required by this substring to convert into all ones. Okay, so, and it is a big of one formula. Okay, it is a we just perform it use this formula. Its complexity is big of 1, is a constant time operation. So what we can do now, okay, it is not sure that we have to select like only this subarray. We can select any subarray, right? Why we are selecting this only? We can select this, we can select this as well, then we can select this as well, or we can select this as well. So how many subarrays are there? There are n minus k plus I, sorry, k plus 1. So these are the number of subarrays of size k. And so what we can do, like we can go through all the subarrays. Like going through all the subarrays would take this much time, and this is nearly big of n. And for every subarray, we do a constant time operation to check the number of operation, and we take minimum of all of that. Okay, so it would be our answer. uh, here actually we are what we'll do, we will put a counter pointer here, like I, then we will let's clear it a little bit. We will just put a I here, and we will move it in the left side, and we will just take, first of all we will take this window, then we will take this window. Actually we are sliding the window, so that is what we're gonna do. And by this we will possibly look for every every substring of size k and find the number of operations required to make it all one. So, and after that we will take, minimum of all of that. Why we will take minimum? Because if any, there might be like there would be a substring which will be taking much more operations, and there would be some substring of size k which will be taking less operations. So we'll take minimum of all of that. And why we can do so? Because traversing through going checking the number of subarrays are n minus k plus 1, and for checking for every subarray it requires a constant time operation. So we can do this, and this would be our answer. So I hope this whole solution is clear to you. And let's see the C++ code right now. So this is the C++ code, and here we actually, first we make a check for one, like if there is a single, if we need a substring of size 1. Okay, like if there is any first s is given like 10101, like whatever given, but k is given 1, like we need a substring of size 1, uh, which is all one, which is having all one. So uh, it is 1, like we want 1 in the substring. So if there is any one, like then we print, yeah, like print 0, like the 0 operations are required. Otherwise we print 1 operation required. If there is no 0, like it is all 0, like we have to make at least 1 so we will flip any of them. If we flip any of them, if we need to do one operation, one flip to 0 become 1. Okay, one flip to 0 will become 1, and only one operation is required. That's why we printed 1. Now moving up to this part, like only this small part for making this prefix array. Now this is sliding window. So it was quite large in understanding, but its code is very simple and short, crisp. So we can see that this prefix of I we have created, created here, like it will take the previous value, and if it is not equal to its previous value, then it will add 1 to it. Okay, and now I move the window from back, like I'm moving this window like this. Okay, so from I will be here, then here, then here, like it will go till here, and that's how, if there are k in this, the remaining, I what will I leave here? I will leave k minus 1 elements here, because we I need because I need not to look upon those, because its minimum size of the subarray should be k. That's why. And now I've just simply used this formula that I've created and taken minimum of all of them, and just printed the answer. And that's all. I hope this is and everything is clear to you. And this flag I have used because to check whether there is any one, and if there is a one, then I have printed 0, like no operations required. Otherwise, one operation required to make 1 0 into 1. Okay, so that's all. Thank you for watching this video. I hope this prefix array, the concept of prefix array and suffix array is clear to you. And see you later in some other editorial. Thank you.